All right, guys, I want to give you an update on the course. We are moving right along. All right, we have already 2 modules completed. We have the switch mode power supply primary side completed, which I did show you in the last update video. And we have the secondary switch mode power supply secondary side is completed. I may add 1 or 2 more videos, but I want to get into the main board, which is what everybody has been waiting for, right? And we're also going to be doing T-Con boards. So guys, make sure that you get in now, because once the course is completed, the price is going to go up to around $247. This is a special pre-launch price. Once you're in, you are in for life on the course. Well, let's just go over basically what the course is about. It's called The Art of Troubleshooting and Repairing Modern Televisions, because I know a lot of you guys have been struggling like I was as far as like trying to find out how to fix a TV or electronic device or a power supply down to component level. And The Art of Troubleshooting and Repairing Televisions or any devices, learning how it works from the beginning to the end, from the power cord all the way to the power button. And then that way you can better understand what you're looking for and what you're not looking for, right? What's supposed to be there and what's not supposed to be there as far as making measurements. And so just like we're going to start off with the AC input circuit, rectifier circuit, and then after it's rectified, we're going to have a DC voltage, which is going to be used to switch the switch mode transformer, and the MOSFET is what actually switches it. All right, we're going to go with MOSFET, and the PWM chip is the chip that is connected to the MOSFET's gate pin, and that's what tells the MOSFET what frequency or the duty cycle to switch the pulse. All right, and then we're also going to go into power factor correction circuits, which is the last part of the first module. PFC circuits, where I really get into detail on the PFC circuits. If you look at the last update video I made, I do have a demo of the course and power factor correction circuits. And for me personally, that's what I had a struggle with, power factor correction circuits, figuring out what it is, what does it do, how does it work, what am I looking for, and this is really going to go over that in detail. And just keep in mind, it's recommended that pretty much the only thing that you really need for this course to get started is a good multimeter and an oscilloscope, a working electronic devices based on measurements, DC voltage measurements, and drive signals. So you're definitely going to need an oscilloscope. And then getting into the power supply on the secondary side, we're going to go into the rectification diodes. Those are the diodes that are coming off of the secondary side windings on the transformer. We're going to go into DC voltage rail outputs, backlight circuit, positive line and return line, and also the feedback loop. All right, using the optocouplers. So guys, this course is going to help you out a whole lot. And my students, I have some wonderful students, even got a YouTuber on here who also enrolled in the course also. And from just what they've been telling me, this course has like been so helpful that it's like, you know, I'm guaranteed you're going to learn some stuff that you never knew, right? I learned a lot making the course. Like I said, this is not something that I put together. I did, research. I got ebooks on just about everything I've been talking about. So I've also learned a lot myself, and this is going to be very valuable information for you. Just by what my students have been telling me. We also have a Facebook group, all right, and we also have a private community inside the course for students only. And so I'm actually going to make this Facebook group public. Well, not public. You're going to have to join, but it's, if you're, just want to just get a sneak peek at what's going on in the Facebook group, you can join and ask questions and put videos on here, because a lot of people have been asking me questions, and I really can't picture what they're talking about. But at least here you can take pictures, post them up here, and I do answer all questions on here. For my students already, in case you're wondering, the community page It's being revamped by Kajabi. That is the platform that the course is on. And so, which is good because that's why I make the Facebook page, because I wasn't getting like notifications like the way I wanted to, right? You know, I had to go to my email and see if anybody made a post and all that. So that should be much better. But you can look here. I do have a few comments about the course. I've got tons of good comments about the course, so that's really motivating me to make this course the best. This is actually going to be the only online TV repair course in the English language. I don't care if you're a beginner in television repair or you've been working on TVs for 10 or 20 years. I can guarantee you this course is going to be some really good information. Just this course is not recommended for anybody that has no experience in electronics. But by me saying that, you can learn very easily just taking electronics, basic electronics course, and you will have to actually, to get the most out of this course, you're going to have to, the best thing to do is just have a television, right? Whether it's, broke, cracked screen or whatever. And that's why you can just follow along with me on each lesson within the modules. So what I'm just going to do, just like last time, I'm actually going to show you a demonstration, a demo of one of these lessons that should add some value to the video and add some value to you so you can see exactly what's going on. So you have to take my word for it or my student's word for it. And do that. I'm going to show you the video, a lesson, right, or some lessons. And our guru buddy of mine was telling me, don't show them free lessons. Don't show them like what's inside the course. Get the email address first. And like I told him, I said, hey, look, I may do that once the course is completed. Okay, but right now, basically, this is for my subscribers. I mean, I love my subscribers. You guys will kept me doing YouTube videos, and so it was very important that I knew that I was actually helping people out, okay, for free, right? So, like I said, I'm not going to do that. I'm just going to show you a demonstration of what's going on inside the course. So each of the lessons are going to include PowerPoint presentations and hands-on videos showing you exactly what's going on. This is a very easy to understand course. I'm not going to be going all over the place talking about resonant frequency and this and that. I'm going to get straight to the point, giving you raw information. And there's no doubt in my mind when you get through with the entire course, especially the power supply sections, both of those modules, you are going to be 100% better at understanding what's going on and what to troubleshoot on any type of failure, like the power supply board, which is completed. Now, each of these different lessons are approximately about 20 minutes long on average. So you got about a little, probably over 8 hours so far of lessons and training that you get into. And a couple of my subscribers and viewers have been asking me, because I'm putting out maybe like one lesson on average a week, sometimes 2, sometimes 3, depends on what kind of time I have. But yes, people are asking me, can I go back to a lesson or whatever? Yes. So this is not like a live presentation on each lesson. This is just a video, right? It's pretty much a video playlist. So you can go back to any lesson you want, look at as many times as you want, right? Pause it. As you can see, I can go to any one of these. I can just open it up and then have a outline on the side, and you can also blow it up. All right, guys, welcome back. So you're really going to get a good understanding of what's going on, and you really are going to learn, and that's a guarantee. And like I said, don't take my word for it. Don't take the students' words for it, because I do have a lot of comments on the course, and that's good comments, and that's really what's motivating me to get this course completed and done, the entire course, so I can get back to my YouTube videos. So with that being said, let's get on to the demonstration. So what you want to do then to verify that you have a backlight problem, whether it's the LEDs or the backlight circuit, is just put your flashlight, a bright flashlight, up to the screen. If you don't have any sound, hit the menu or something and see if you can see an image or shadow on the screen using your flashlight all the way up to the screen. Now, I do want to clarify there's a big difference between, always double check. If you're not getting a picture on your TV when you turn it on, make sure the backlights aren't lit up, all right? Turn the lights off, whatever you have to do in a dark room, because there's a big difference between a black screen with a backlight problem and a screen that's lit up with no video, right? With no image or picture or menu or nothing. I don't know how many times people have told me they had a backlight problem, but when I seen the TV, the screen was actually lit up. There just was no picture on it. And you may also still have sound too, but that is a totally different problem, because if the screen is lit, that means the backlights are working, and you may have a problem with the with the actual LCD panel, T-con board, or something in between. There's always going to be a diode on any television or every television that is specifically for the LED circuit. And as you can see, this is our diode right here. All right, this one here. And that is producing the DC voltage going to the LED circuit. And as you can see on the LED circuit, we have another diode right here, an inductor and capacitor. So just like normally, we have a diode here coming off the transformer. The voltage is then being rectified by the diode and then smoothed out or filtered by capacitors. And then right before we get to the LED plug or the LEDs, we have another diode and another fit of capacitors and some inductors. And we also have a MOSFET. Sounding familiar? As you can see here off of this diode here for the LED circuit, you're going to have about 65 volts. But at the actual plug going to the actual LEDs, we see we have 95 volts. So it is actually amplifying that voltage or increasing that voltage. And how does it do that? This is going to look so familiar to you. You're going to have an inductor, a MOSFET, a diode, and at the gate of the MOSFET, we have a controller IC, right? Or in this case, a LED driver IC, right? And then you can see where it says gate. The gate of this IC, the gate pin of this IC is driving the gate of this MOSFET, which is taking that voltage, switching that voltage on and off at this inductor, increasing current at the anode of this diode and at the cathode, along with another inductor to keep the current constant. This inductor is for, and the capacitor is going to have a steady higher voltage. So then, first thing we want to do, obviously, check is see if we have voltage here at the strips. Like you always see me doing on my videos, I always check for voltage here to make sure that we have voltage even going to the strips. Like I said, this one is approximately 95 volts, but it may be higher. But we just want to check to make sure we have voltage at the strips. Or if we do, we want to make sure that this MOSFET is being switched on and off. Make sure it's not shorted. Make sure that we have a drive signal at the gate and also at the drain pin too, right? Of course, I always make sure this diode's not open, right? And none of these inductors are open. All right. So most likely, our problem is we're not going to have a drive signal at the gate, especially if you're getting the same voltage between this diode here that is dedicated to the LED circuit, this first diode, and the diode here, or the voltage here at the plug. If those voltages are the same, there's a good chance that you are not getting a drive signal to the actual MOSFET. The pin number 3 here for the gate drive, right? But we also need a few more things in order for this to come on. Okay, this is our switching transformer for our standby voltage. And here are the diodes that are rectifying the standby voltage to 3.3 volts. Capacitor to charge up. And helps smooth out the DC more. Here's our diodes coming off of this transformer for our 12 volt regulated voltage, right? Which also comes up in standby because the power factor correction kicks in as soon as we plug the TV set in. And here is our diode here, right here, coming off this transformer also, and that is for our LED circuit. Okay, so if we look at the legend on this plug here going to the main board, right here, we notice that we have our, let's see where we're at, 3.3 volt standby. We have our, where's it at? Where's our power on? And we also have this one says BL on for backlight on. Okay, so we need that voltage coming from the main board to start the backlight circuit up. See, back to our LED diode. They're coming right, I drew a line actually, they're going right to the transformer. Okay, so we got AC coming in this diode and rectified DC voltage coming out. All right, and then the capacitors for this diode are somewhere between, I didn't mark those, I didn't mark those. But we got a capacitor coming out, two capacitors, two electrolytic capacitors coming out of this diode on the anode, on the cathode pin, and then that is going to the drain pin of these MOSFETs. All right, guys, so what I got here, I got this meter. It's hooked up to the cathode of the diode that's going right to the LEDs. Right there. Okay, I've got my scope hooked up to the gate pin, right, of one of these MOSFETs. Okay, and I've got this meter right here that's hooked up to the backlight on pin in the plug. Right here, okay? So, TV is unplugged. Okay, TV is unplugged. I'm going to plug it in. And when I plug it in, just assuming that the IC, which we'll go over in a minute, that the LED driver S IC does have the 12 volts VCC. We definitely need that before anything else can happen, before the backlights can come on or whatever, right? What's going to happen is this should change. We should have this first, the backlight on voltage, and then once we get the backlight on voltage, the IC is going to start switching this MOSFET. So we should see a waveform here, and then once that happens, the the LED plus line right here at this last diode should go up to approximately, should increase up to 95 volts on this TV, or it should increase to a certain voltage or whatever TV that you're using. But look at this. I'm going to go ahead and plug it in. All right. Now, as you can see, we plug it in. The only thing that changes is the voltage on the LEDs, the LED plus line, okay, which is this diode. This diode is going right to the LED plus line. So we have 63 volts. The TV is in standby. All right, so what I'm going to do now is I'm actually going to power it up. Once I power it on, the main board is going to send through this cable the power supply on and also the backlight on, which we're concerned right now is the backlight on command or voltage, right, to the IC, which is then going to start driving the MOSFET, when we should see a gate signal on the scope. So we're going to hit power. So it'll work from right here. Try it from here. There we go. 3.3 volts. We got a signal. And now we are at 98 volts at the output. Now, if I take this off very carefully, so look at this meter right here. We have the 95 volts is also going to this plug right here, but we have the 95 volts here. That is our LED plus, and as you can see, turn the TV off. We do have backlights, as you can see right here. Okay. So what I was saying is we have 95 volts there, but we still have our 65 volts. See at the diode right there. Okay, coming right off of the switching transformer. So it's still 60 volts, but it actually increased to 94 volts. Let's just go ahead and turn it off. Our backlight on voltage is gone. No more drive, and now because we're not driving that MOSFET or driving that inductor that's connected to the drain of the MOSFET, now our voltage has went back down to 60 something volts, 63 volts, and same voltage right at the LED diode. Now, if we look closer, this one actually has two LED driver ICs. Okay, it's one for each MOSFET. Okay, here's our LED driver IC. All right, this is on a different board, so it just uses the one IC because it just has the 4 lines. Okay, let's zoom in first on this IC so we can see where our crucial pins are. That will be the driver. That will be pin 26. That is the gate drive signal going to the MOSFET. Okay, that's amplifying the LED voltage or backlight voltage. VCC, which is pin 24, that's what we need first, all right, before anything. And then our enable pin is pin 11. Okay, that should be the voltage from the main board. The backlight on voltage from the main board should be going pretty much straight there to pin 11, so that we can, once we hit the enable, so that then we can actually tell the IC to start driving that MOSFET. There we go. There we go. Right there. Right from the plug to the enable pin. That's the backlight on voltage. All right, so let's look at the IC. We'll just take a look at one of them. So pin number 11, this is pin 1 where the dot is at. All right. So pin 11, obviously I got it marked in blue. That is the enable. So once we hit the power, we should have approximately 3 volts here, maybe 3.3, 3.2. And VCC, we also need that first when the TV is in standby. Okay, so we need to have, this IC has to have VCC first thing, right? All right, and then after we hit the power, the backlight on is going to the enable pin, and then this right here, VCC was pin 24, and then 26, pin 26 is where we should be getting our drive signal from. That's pin 26. I got that marked sort of like in black. All right, so let's just see. So the TV is actually plugged in now. And the first I'm going to check for is make sure that our IC has the VCC, which is right here, and that is pin 24. Okay, so that is the same 12.7 volts that we are getting right here at our 12 volt line. Diodes right here, 12.781 volts. Make sure the IC has VCC before you even power it up. Now, let's go to pin number 11. That's our enable pin, which I've got marked here in blue. All right, that is pin 11. I got my meter at on this little test point. There's actually some little test point dots here. Okay, so what I'm going to do now is actually turn the TV on, and that should be produced by our backlight on signal or voltage. So I'm going to power it up. Okay, so once that happens, we should be getting a drive signal, and that drive signal is at pin 26. And I should have that marked right here in black. Right here, that should be pin 26. So the TV is on. I'm actually going to power it off. Okay. Backlights are off. And let's go to pin 26. Little test point right here. My probe is on ×1. Okay, it's a smaller signal, right? So let's leave it on ×1. And of course, it's grounded to the metal chassis because we're on the secondary side of the power supply. So as you can see, we don't have anything yet on the scope because the TV is off, and we don't have our power supply on yet. I'm sorry, backlight on yet. So I'm gonna go ahead and hit the power. There we go. So that is very important because that's going to be a most common problem with a set that has no backlight and you're double checking it and the LEDs are good. Is it going to be that the MOSFET that is amplifying the voltage for the LED plus line, or it could be on the minus side too. It all depends how the TV is made, but just look for the MOSFETs and it should have a drive signal. If it's not getting a drive signal, most likely if the MOSFET is good, you're going to have a bad driver IC. All right, and but anyway, I always check the gate pin of that MOSFET and check for any burnt or open surface mount resistors also. All right, guys, hope you got a lot of value out of that. Just so you know, that demo I just showed you was kind of chopped up. It wasn't all in one lesson because I didn't want to take up too much time on this video. But I do go into much detail on what I was talking about inside of the course. And the reason I decided to show you guys the LED circuit as a demonstration is because I was watching this guy on YouTube who's one of my favorites. I'm a subscribe to him. I'm not going to mention his name, but he actually had a TV with a backlight problem. He was doing a YouTube video on it, and he had voltage. The backlights were good. He checked the backlights with the LED tester, and he had voltage on the LEDs on the plug for the positive line, and which was kind of low. So what he did is he started just changing stuff. He changed the MOSFET for the LED circuit, or for the LEDs, and he had to go through a lot of stuff because I think it was on a heat sink or it was backwards. He had to use his hot air gun. I think it was a surface mounted MOSFET. Two of them. He ended up changing the capacitor, and he finally decided to change the driver IC for the LED circuit, the LED driver IC, and then it worked. But the thing was, if he had just checked for a drive signal at the gate of the MOSFETs, then, or even at the drain of the MOSFET, then he would have known that the LED driver IC was possibly bad, and he would have changed that first. So it just goes, how little things, can affect the way you troubleshoot, just knowing things, knowing the art of how each circuit works. And that was just one method of the LED backlight circuit. They do use another method. I was just looking at it right here. Mainly they use this method, the other method for most like TCL TVs and Hisense televisions. So I do go over that. And I want to add another video to that, guys. But another thing to make sure that you do, besides, actually following along with the TV to get the most out of this course, is make sure that you look at each and every lesson, right? Don't start skipping around, because then, it's going to start getting confusing to you when you're on a lesson. Make sure that you check out the community. I do have videos on there, and I will post some videos on there that will not be on YouTube. They're going to be basically troubleshooting videos. They're not going to be backlight videos. And like I said, make sure you join the Facebook group. Because if you have any questions, but I can't answer them, we've got plenty TV repairmen that are willing to answer any questions in the Facebook group. And I also want to give a shout out to some of my students. So if I spell or pronounce your name wrong, please forgive me. So I'm going to start with these are like the newest students who have joined within the past like 30 days or 45 days that I've really been, watching all of the lessons, and I can see how many times they've logged in. But let's start with Roberto Manzarinis, my man Garrett LaSalle, my man Tim Loyal, David Pendon, appreciate you, Borislav, okay, I just put K because I can't pronounce his last name, it's too long. Appreciate you, Borislav, welcome aboard. Thuring Gansey is another one I can't pronounce his last name definitely. His first name, I know I'm messing his name up. Sorry about that. But thanks for joining. Rick Garcia, Benny Feliciano, Eduardo Rivera, Devin Smith is our newest member so far. And a big shout out to my man Robbie Atkin, who's been with me since day one, giving me feedback and encouraging me. So guys, get in while the price is right now. And I don't care if you're retired or, you just want to get back to electronics. And this course is definitely going to be what you need, and to, just have fun, right? Or maybe you want to learn something so you can start making YouTube videos, right? So until then, guys, I will see you guys in the course. Big Dog out.